All right, hello everybody again. How's it going? Last lesson. That's so you should be super excited. 3.12 inverse of a quadratic function. We're just gonna quickly run through this lesson, and we're gonna yeah, I think that's it. There's a couple of homework questions here, but again. Hopefully we're okay with doing inverse. This is technically part of the first unit, just kind of like an extension into quadratics, focusing on quadratics. But we've seen a lot of this stuff before. So let's see. For the function, we got a graph f. So that's at a y-intercept of 2, you go, 1, 1, 1, 1, and then 2, and then 4 up. So 1, 2, 3, 4. It's going to be symmetrical on this side. It's 2 here. It's not symmetrical. Okay, that's basically all we need. We need 5 points. That's enough, again, to kind of make our inverse, because we have our vertex here at 0, 2. We have 1, 3, -1, 3, 2, 6, -2, 6. We have 5 points. That's more than enough to graph our inverse, because we know our inverse, we're just going to have to flip all the points. So we start at 2, 0. That is our inverse point. So we start over here, and then we plot the point 3, 1. So 3, 1, and 3, -1 right there. There's 2 points for 3. So we know it's not a function because it doesn't pass the vertical line test. We also have 6, 2, and 6, -2. So here is our inverse function, nice and easy. So this is f of x. This is f inverse x. Remember to label the stuff. And you should probably put points around there too, but that's easy. So determine the defining equation of f inverse by interchanging the variables. Okay, so y equals x squared. We know how to do this. Hopefully y equals x squared plus 2. Interchange variables. X equals y squared plus 2. X minus 2 equals y squared. Take square root of both sides. Y equals plus or minus square root of x minus 2. And then f inverse x equals plus or minus square root of x minus 2. Ta-da! All right, let's look at this question. So -2 x minus 1 squared plus 7. The vertex here is 1, 7. I know that. So I'll graph this first as usual. So 1, 7 is my vertex. And now as I go 1 to the right, I have to go 2 down because it's a factor. I'm also stretching by a factor of -2, right? So these are points here. And as I go 2, I have to go, instead of 4, I would go 8 down. So instead of 7, I'd jump down to -1. Again, table of values helps here. Whoops. And that. And then basically what I'm interested in here really is the points. Here I have 2, 5, -2, 0, 5. Those are symmetrical points. And at -1, I should have 3, -1, and -1, -1. So I flip all the points. So I have 7, 1, x of 7, y of 1, x of 5, y of 2 and 0, and then here and here will be my points. So that will be this is my f of x, or g of x. This is my g inverse x, right there. I should have used different colors. Too late. Hopefully you understand that. Okay, again, okay, hopefully we see what I did here. I took like all these points and I switched the x and the y and I plotted those different points. So I plotted, for the inverse, I plotted 7, 1, 5, 2, 5, 0, -1, 3, -1, -1, and I plotted that graph. So hopefully we're okay with all this stuff from unit 1. Determine the defining equation. Okay, we've done this before. Y equals -2, x minus 1 squared plus 7. Switch variables. Move stuff over to the other side. First move the -7. Then divide by -2. So I'm going to move the negative to the top so it looks better. Take square root. So y minus 1 equals plus or minus square root -x minus 7 over 2. So y equals 1 plus or minus square root of negative of x minus 7 over 2. And this is my g inverse x equals this 1 plus or minus, yeah, whatever, you get the idea. Graph that to check, and you can hopefully see that I do have, I have graphed, indeed, this function right there. If you put a table of values and start putting in values, it makes sense. How do we restrict? Is this the last page? Sorry, I'm getting super tired. I guess that's the disadvantage of doing all these videos straight. I've been at it for like, I don't even know when I started, but that's okay. Sorry. How do we restrict the domain of h of x so that h inverse would be a function? Okay, let's take a look at this. And this is important because this is a very important question. You put a star beside this. And we've done kind of restricting domain questions before, but we're going to do this one again. So the idea here is, if we take a look at this graph, this vertex here is going to be -2, -1. That's our vertex. So -2, -1. And our parabola is going to look something like this. This is our original function. So actually, you know what, I'll kind of do different colors because let's draw one half in blue of the parabola. This is like the right half of the parabola, and the red is the left half of the parabola, right? And now when I take my inverse point is going to be, my vertex kind of the sideways parabola is going to be -1, -2. So let's go -1 on the x, -2 on the y. So like somewhere over here, let's say. And again, if you kind of map the points over, you'll see what we're doing here is, if we think about it and we keep the same colors, you'll have half the parabola that looks like that, and the other half of the parabola, well, sideways parabola, I should say, that looks like that. And the idea here is this blue line from our original function, like h of x, mapped onto our thicker blue line. Or did it? I can't tell. Yeah, I think it did. Yeah, it's not. Yeah, it did. Sorry, I confused there myself for a second, but it does. So this blue line from our original parabola, what happened? Mapped onto this thick blue line on my inversed parabola, and this red line from my original parabola mapped onto this thick red line from the new parabola. Again, it's not as easy, so you might think, oh, what if I just like take this parabola and like turn it 90 degrees? Do I get that? No. So that's not the inverse. And if you actually map the points, you'll see what I mean. Because like if you look at this point over here, that point on the blue line is 0, 3 or whatever. And if you flip that 3, 0, that would be like this point on the blue line over here. And so you can see that the blue line does map onto the blue line of h inverse x. And so the mapping is done correctly and color-coded. So as you can see here now, this inverse function fails the vertical line test because you can see that if you draw like a vertical line, it passes through both the blue half and the red half. And the idea is we want to essentially restrict the domain of our original guy so that we only have one of these lines. We either have the blue one or the red one. And the key here is going to be our, it's always like this, the key here is always going to be our axis of symmetry. So we'll see here that our axis of symmetry centers around x equals -2. So a restriction of our original parabola is XER, that's a domain. We can restrict it to x greater than or equal to -2. If this is our restriction, we'll have only the blue line in our original parabola because this will be chopped, the red part will be chopped off because we're restricted the domain to greater than -2, and therefore we'll only have the thick blue line in our inverse equation, right? And that, if we don't have the red, that passes the vertical line test. We can also restrict the domain the other way. We can say XER, x less than or equal to -2. In this case, only the red part exists, only the red half exists on the inverse parabola, the blue part doesn't exist, and therefore that also passes the vertical line test. So either one. So important here is whenever we're restricting the domain so that the inverse is a function of a quadratic, we always look at the axis of symmetry from the original. Don't get confused here. This is still the original parabola. And then we say we're still restricting the domain of the original parabola so that our range of the second one is restricted so that we don't have conflicting values there. So hopefully that's clear. Find the defining equation of h inverse where h of x equals that x greater than or equal to -2. So this is an interesting question. What do you want, Kat? Where are you? Sorry, just give me a second. Okay, before we move on to this, I do realize we did a bit of something wrong here, because technically we were supposed to find the equation by switching operations, which is a little bit different than what we've done over here. We did this by interchanging the variables. So what we're going to do is we're going to switch the operation. And here again, it's the same idea, but we're kind of moving backward to forward with an understanding of what the answer is and where we're going to go with this. So again, we're going to start with y equals x, which is what we start with. But again, we're going to switch all the operations. So first, we start with the +7. We're going to make this -7. Then we multiplied by -2. We're going to divide by -2. We took the squared. We're going to take the square root and throw a plus or minus. Then we subtracted 1, and now we add 1. So, I mean, this is essentially what we're doing in the long method over here, but this is just a shortcut to do it, quickly, because what we're doing each step is we're switching an operation, moving it to the other side, and if we know the order in which those operations work, we can just switch them directly instead of going through, all the hassle of writing down all these steps. So we can do this a lot quicker. So it's important to know how to do that, and hopefully we're okay with how we're doing that. Just think of it as like doing all the steps, but in your head, kind of. So first, normally you would have subtracted 7 from both sides. Here, you're just going to start off with, say, like x minus 7. Then you divide by -2. So here's a multiply by -2. So throw a divided by -2. There's a square. Throw a square root on it, plus or minus. Then you have -1. Then you're going to put +1 at the end. That kind of thing. So that's what switching the operations is. So here, we can try looking at this. This is again the same question that we had before. But again, if we do switching operations, we get y equals x plus 1 divided by 3 square root, plus or minus minus 2, I believe. So this is our h inverse, but we have a restriction on the domain here so that x is greater than or equal to -2. So again, if you want to think about our parabola, the domain is restricted to the right half of the parabola. So our inverse, that's not actually, yeah, but okay. That's not where the vertex is exactly. This is a random parabola. The domain is restricting us to the right half of this parabola, so our range will be restricted to the top, the top half of our inverse parabola. So technically, I'm going to get rid of this plus sign. I'm going to get rid of this minus sign here, and so my h inverse x is only going to be positive x plus 1 over 3 minus 2. Not the negative, because I've restricted my domain to the right, so only the top of my inverse parabola exists, kind of, not the other half. So like this thin line and this other thin line are like crossed out because this is crossed out, right? Because of my restriction on my domain. So that's how we're going to think about that one. And last but not least, I don't even know, do I want to do the homework? We'll see. Last but not least, here's the function f of x equals square root of x plus 3 plus 1, graph f. So there's different ways you can do this. You can start with y equals square root of x and then transform the function so that you have an x minus x comma y maps. If you know your mapping equation, you go x minus 3 and y plus 1. So you have these points and now you're transforming them basically like so. And so we can graph this function using this. So our points are going to be like 0, 0, 1, 1, 4, 2, parent function. And then I'm going to map these points to this guy over here, so I'm going to do -3, 1, this goes -3, so -2, 1, 6, I think I mapped that correctly. But yeah, okay, so let's graph these points. -3, 1, -2, 2, 1, 3, something feels fishy here. Oh, 1, 3, there we go. So 1, 3, there we go, that's better, and 6, 4. Okay, that looks more like a square root function now. That is my parent function f of x. And graph f inverse x. So the idea here is to graph f inverse x, we just flip all these points, right? So f inverse will have, the points on f inverse will be 1, -3, 2, -2, 3, 1, and 4, 6. That's the easiest way to graph f inverse once we've already graphed f. So let's just plot that 1, -3, 2, -2, 3, 1, 4, 6, like so, and determine the defining equation. Again, we're just going to start y equals x, and we're kind of going to flip, we're going to change the sign. So first we have a -3, first we have, again, we're going to start from what we would do first. So technically we had a +1, so we're going to do a -1. We have a square root, so we're going to square that. Then we have a +3, which is going to be a -3. And this is our equation of the parabola. And you can kind of see here that because we don't have, so if you look at this original function, if you look at this original function here, this was a square root, but it's only half of a square root function because there's no minus, right? So this has been restricted to the upper half of that sideways parabola, and so we will be restricted to the right half of our original parabola because, again, we're doing the inverse the other way. Now our original function is a square root, So our inverse function will be a parabola, but for a original function to be a proper square root, we can only have half of a square root function, not the other half, like this half is gone, and therefore from our parabola, the other half of the parabola is gone, and we have like a kind of restriction on our, domain of our parabola where x has to be greater than or equal to 1. That's our restriction. We can see that on the graph here. So that's basically it. Hopefully graphing isn't hard. I know I skimmed through this, but this is all review from our even our culminating, right? So hopefully we're good with all this. I'm going to take a glance at page 160. Hopefully I won't need to spend too much time on it. I don't know what all that's about. Oh, look at... Oh, I think it's the wrong unit. You know what? 2 to 8. Oh no, it is. Never mind. Graph the inverse. Okay, we can do this. Determine equation. We can do that. 2 to 8, was it? 10 and 17. So you can do this stuff. Okay, hopefully we're okay with doing all these things. So you have to find f inverse x, and then instead of x, put 2a 7, blah, blah, blah. You know, we're going to do this. Okay, I think this should be good. Further restriction, restrict the domain. That describes times in terms of height. So this would be taking the inverse. So you're just going to take the inverse of that. Obviously, you'll have it in vertex form, so it's easy to take the inverse of. Just switch the functions. And yeah, I don't think there's any difficult questions here. I know I didn't really look at it at all, but graph 17, I think, was a question. So let's look at this. 4 minus 4y plus y squared. So, that's, what? I'm so confused. This looks like a weird kind of expression, because in this expression we are already kind of given x in terms of y. So this is usually how an inverse would look like, but this time our actual function is given to be looking like funky type. So I'm going to have to think for a bit. So if we want to graph this relation, what is the best way to go about graphing it? Probably a table of values. I am going to do some factoring here, because this is actually x equals y minus 2 squared. Okay, so now it looks slightly better. But the idea here is this would actually look like a sideways parabola. So the graph of this would actually, so our vertex, if this was the right way up, our vertex would be 2, 0, but now 0, 2 is our vertex, and this would be the graph of the function. So let's call this like f of y. So this would be the graph of f of y. Or this would be the graph of our original function, and determine the equation of the inverse. The inverse would actually be, you actually just y equals x minus 2 squared, I think. Is it? Because I switched the variables. That's all I did. I can't just switch the variables. Hold on a second. Bah. I hate the switching variables nonsense. It confuses me. Okay, so we switched back to what our original thing was supposed to be. And now we just have to isolate for x. So square root of y plus 2 was x? Yeah. Yeah. So this is like opposite world. So this is our inverse function. And if you look at the inverse, our inverse function looks like, would look like this, actually. Like that. That would be what our inverse function would look like. I think it includes both values because if you look at x, there's, what am I having here? There's there's two y, there's two x values for one y value, which kind of makes sense because I have like a plus or minus here. So for every y value I take, there'll be two x values. So yeah, this inverse is a function. Okay, it's basically like opposite land. This is my original equation because because my x and y variables are flipped, like what looks like a parabola here is actually like a sideways parabola, and what looks like a square root function or a sideways parabola is actually like a regular parabola. So the idea here is that my original relation here, which looks like this, is actually like a sideways parabola over here. So you can do the domain and range of this. Like the domain is x greater than xer, x greater than or equal to 2, and range is just yer. Determine the equation of the inverse. This is the equation of the inverse, and it is a function because this is actually just a fancy way of representing y equals x squared, or this kind of this function, and this is essentially my inverse function, and so that's that. So yeah, that was kind of confusing. Okay, hopefully, if again, this I'd say it's probably a very good assignment question. If we throw some curveballs, this would probably be something that looks like that. Again, but so hopefully you're seeing how to do this now. Again, try and use a table of values to see, and you'll kind of see that this shape kind of forms. So hopefully we're okay with that idea to check. But keep this at the back of your mind when you're studying for assignments and stuff. But I'm gonna sign off for now. Hopefully you're okay with the rest of the lesson. Just give me a second. So if ouch, sorry, my cat is misbehaving. Sorry about that. So I see here that you do, so again, I'm not sure when the assignments, tests, how they're going to be set up, but we will definitely get more information next week, depending on things. So I will tell the review is not posted yet, but it will be open soon. And if you have any questions with that, please let me know in the comments of any one of the videos, or we'll take it up, or Mr. Chimoli will take it up with you when we're actually doing lessons somehow next week. But again, until then, just keep reviewing whatever material is up and running. As Mr. Chimoli's posting the lessons step by step, and you're just gonna keep on top of that, and hopefully I will continue with these videos for whenever the lessons are posted. I understand that until now, at least, I've been kind of posting the videos after, like way after actually the lessons have been open, but as now I have, again, I will confess that I'm making all these videos at a stretch. So I believe I've caught up to where your lessons are posted. So from now, I will, as soon as the lesson is, your lesson becomes open, or even before that, I will post a video so that you can, again, like I said, as the lessons are being posted, you're looking over them, looking at the solutions. If you have any questions about that, you're coming back to these videos and making sure you understand everything. So, stay safe. Stay healthy. Follow social distancing rules, please. And, hopefully we'll see each other again before I guess, the end. Before the end. I probably won't, unless school opens back, I probably won't see you guys again. But, hopefully we will catch up before like official summer is in June. If schools do reopen for the month of May and June, I will definitely drop by and say hello. But yeah, until then, peace. I'll speak to you guys soon. Next unit, exciting. I don't actually know what the next unit. It's probably like, what is the next unit? I don't even know. It's like exponential functions. There we go. That's the next unit. So I will see you for exponential functions. Fun stuff. All right. Catch you guys later. Talk to you soon. Peace.